Welcome to Project Python. This is a series where I, a coding enthusiast, take on several coding challenges to challenge my coding skills and along the way explain my learnings. Each episode focuses on a different problem, and that's about it. So without wasting any time, let's get into this episode of Project Python. Before we start, if you've been enjoying the content and would like to support me, please consider subscribing to the channel and liking the video. You can also follow me on my socials shown on the screen and linked in the description below for similar but much shorter content and to get any updates about me or the channel. Thank you so much, and with that, let's get into today's video. Today's challenge is to solve the Leetcode problem valid parentheses. The input is a string and the output is a boolean value. The problem is as follows. Given a string s containing just parentheses, so this includes curved, curly, and square parentheses, our task is to determine if the input string is valid. And for the input string to be valid, the following conditions must be true. All open brackets must be enclosed by the same type of brackets. Open brackets must be closed in the correct order. So for example, if we had this input string, then our output would be true, as all open brackets are closed by the same type of brackets and in the correct order. However, if this was our input string, then our output would be false, because the curved bracket is closed before the square bracket, which violates the second condition. In order to solve this problem, we'll be using a data structure called a stack. But before we talk more about stacks, let's try and develop an intuitive understanding for the solution. So how would we solve the problem? Here's what I would do. I would start by going through each character in the string and sort of making a list in my head. So if I saw an open square bracket, I'd add a closed square bracket in that list, and that's what I'd be looking for now. So if I found any other closed bracket, then I'd know the output needs to be false. Let's say, however, that I've now found an open curly bracket. Then I'd add to the top of my list a closed curly bracket, and now that's what I'd be looking for instead of the closed square bracket. And once again, if I found any other type of closed bracket, then I'd output false. Now each time I find the right closed bracket, I would take it off my list, and if I can cross all the items on my list off in the right order, then I'd output true. This arbitrary list that I created in my head can be replicated in code using the data structure called a stack. As the name suggests, we stack up items in a stack. What is unique about stacks is that they are a last in, first out data structure, meaning items that are added in last are removed first. Adding an item would be to push an item in the stack, and removing would be to pop an item because you are popping off the topmost item or the last item that was added. A stack can be implemented in Python using a list. In order to add an item to the end of a list or to the top of a stack, we can use the append method. And to remove the top item in a stack or the last item in a list, you can use the pop method. So for example, here we have an empty stack or Python list. We can push an item to the stack using the append method, like so. And let's say we do that a couple more times. We can then remove the topmost item in the stack using the pop method. Now if you remember, every time we found a certain open bracket, we needed to find the same type of closed bracket before any other closed bracket. Or in other words, we would stack up the closed brackets in the order we found their corresponding open brackets and would need to pop them out in the last in, first out manner until our stack was empty. If we were able to do this, we would output true. And if the order in which the closed brackets were found did not match our stack, we would output false. Let's try and understand this better through a really quick example. Here we have our input string that contains an open curved and squared bracket and then a closed square and curved bracket. Starting with the first character, we can see that it is an open curved bracket. And so since we would now need to find a closed curved bracket, we would add that to the top of our stack. Then we move on to the next character. Again, this is an open square bracket, so we would add a closed square bracket to the top of our stack. The third character is a closed square bracket, and now we check with our stack to see if it matches the top item, and yes it does, so we can pop this element. The last character is a closed curved bracket, which also matches the top item of our stack, so we can pop it off our stack. With this, we have come to the end of the string and our stack is empty, meaning all open brackets have been closed and have done so in the correct order. To generalize this, we start by iterating through all the characters in the string. For each character, we first identify whether it is an open bracket. If it is, then we add the corresponding closed bracket to the top of our stack. If it isn't an open bracket and therefore is a closed bracket, we check if it matches the topmost item of our stack. If it does match, then we can pop that item from the stack, and if it doesn't, then we can stop and output false. If we make it to the end of the string and our stack is not empty, then also we would stop and output false, as not all open brackets have been closed. But if the stack is empty, then this means all open brackets have been closed and in the right order. Therefore, we can output true. So that's it. Now that we have everything we need, let's start coding. The first step, as always, is to define our function using the def keyword followed by the name of the function. In this case, I will be calling it isValid. This function takes one argument, and that is a string. Next, we're going to create an empty list called stack. And as you can probably tell, this is the list we will use to implement a stack in Python. Now, in order to be able to identify the open brackets and add the corresponding closed brackets, we're going to create a dictionary called brackets with 3 elements where the keys are the different open bracket types and the values are the corresponding closed brackets. Now, we need to loop through all the characters in the string, and to do this, let's use a for loop. For each character, we first want to check if it is an open bracket. This can be done by using an if statement that checks if the character is one of the keys in our dictionary called brackets. If it is, then we can add the corresponding value, which remember is the corresponding closed bracket, to our stack using the append method, which will add it to the top of our stack. If this is not the case, then we need to check if the character is the last item added in the stack. So let's use an elif statement that checks if the character is not the last item in the stack. If this is true, then we can return false. But wait, what if there are no open brackets in our input string and only closed brackets? To handle this case, we will also check if the stack is empty by using the not keyword. Not stack will return true when the stack is empty and false when the stack has items in it. So if it returns true, that means the stack is empty. But we have found a character that isn't an open bracket, and this means we have found a closed bracket before an open bracket, and so the string is not valid and we would output false. Finally, when the for loop ends, we need to check if our stack is empty or not to handle the case where there are more open brackets than closed brackets, in which case our stack would not be empty, so we can simply return not stack. Once again, if the stack is empty, this will return true, which is what we want as it means all open brackets have been closed in the right order. If the stack is not empty, then it will output false, meaning not all open brackets have been closed, and so the string is not valid. And with that, we have completed coding. All we need to do now is check if our function works by passing in different input strings. As you can see, our function works. And this brings us to the end of today's episode. If you enjoyed the video, please consider giving it a like and subscribing to the channel for more such content. Follow me on all my socials as shown on the screen and linked in the description below. And as always, leave in the comments below any alternative solutions you may have found to the problem or any challenges you would like me to take on in future episodes of Project Python.